Okay, well, hey, so we're up for day 14 of Advent of Code. Yesterday I had a really fun challenge. I think just a quick announcement, I guess, that tomorrow I will be traveling across the country, and unfortunately that means I won't be able to do a stream tomorrow night. So no stream tomorrow, but today we're about to start, and I'm kind of a little hype. So here we go. Day 14, extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization technology that would, by the way, the word polymerization, I only know it from Yu-Gi-Oh! So let's see. That would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, which is my input. You just need to work out what polymer would result after repeating the pair insertion process a few times. For example, in NCB, the first line is the polymer template. This is the starting point of the process. The following section defines the pair insertion rules. A rule like AB to C means that when elements A and B are immediately adjacent, element C should be inserted between them. So starting with the polymer template, N and CB, the first step simultaneously considers all three pairs. The first pair, NN matches NN to C, so element C is inserted between the first and second ends. The second pair NC matches the rule NC to B, so the element B is inserted between N and C. The third pair CB matches CP to H, so element H is inserted between them. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. Okay, here are the results of a few steps using the above rules. This polymer grows quickly. After step 5, it has length 97. After step 10, it has length 3073. After step 10, B occurs that many times, C that many times, H that many times, and N that many times, taking the quantity of the most common element and subtracting the quantity of the least common element produces this. After applying 10 steps of pair insertion to the polymer template and apply 10 steps and find the most and least common elements in the result. What do you get if you take the quantity? Okay, so we want to do it. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, so we're just gonna say template, we'll call it chain, is going to be data 0. And then from data 2 onwards, right, so this is one way to just skip the first two rows, first two elements of this array. Now let's see how we want to store this information. I think as strings would make sense because we can check for the, yeah, I think as strings would make sense. So we're just going to call this rules. Let's say string to string. Now I'm thinking that an easier way to do this is to actually save the mapping from a two. So instead of a two character string, like instead of PF to P, I want to store PF to PPF, because then I can just build my string. Or can I? Let me just check this example. I might want to, well, it doesn't really matter. We can store it like this. Yeah, we'll store it the way that it's written. So I'm going to call it key and value, even though it's a little bit of a misnomer. So my new favorite function is scanf. String to string, I believe, is what it looks like. Yep. Write the first one into k and the second one into v. Rules k equals v. Easy. So we're going to print out all my rules, and then we're going to print out the chain and see what we get. Cool. So we've got it. How do we want to do this? I think we want to do this one character at a time. So I'm gonna do this with indexes, I think, rather than yeah, I just want to check if I have a string and I index it, let's say with a slice like this. Is that a string or is that a something else? What is that type? Is it going to like that? Like, is that a string? That is a string. Cool. But if you index into one of them, then it's no longer a string. Then it's a byte. Okay. But if you index it as a slice, even if it's just one character long, it's a string. Okay. Cool. Yeah. So I'm just gonna loop over it. So what do? We say pair is going to be chain I to I plus 2. That is the pair. Do we have every possible? We must have every possible pairing, right? Yeah, so insert is going to be rules pair. I need a new string. So next is going to be an empty string. So next plus equals pair the first character as a string. And then the second character. And I think that's it. This is going to be to length chain minus 1 because the last pair, the last character doesn't have a pair, right? With pairs, you have one less element than the whole thing. And then next plus equals the last element of chain, which is going to be length of chain minus 1 to the end. So this is doing it once. Let's just take a look at what that looks like. Does that look reasonable? Let's see. I want I want BS. BS inserts a P. Cool. So there's a P inserted, and the SO also is supposed to insert a P. Good. And then ON inserts an F. Good. And we have PK at the end, which inserts a V. PK. I just noticed this is alphabetical. PK inserts a V. So I feel like that is correct. A correct single step. So I'm going to turn that into a function. In is a string, and then out is also a string. We'll chuck it in here. We'll pass in the rules because it's easiest this way. So that's parsing. So next equals step chain rules. Should work. Just need to double check that that works first. Hey, look, for the first time, I'm actually I'm actually abstracting things properly. All right, that feels right. So 10 times, right? Ah. It kind of looks reasonable. I wonder if there's a shortcut to this, but I'm not sure. Okay, let's make another function and we'll call this count. And the output is going to be, we'll keep them as strings just because it's easier that way. It to an int, cool. So the output map is going to be this for every character, oops, in string. Just gonna plus plus. And this is the reason you can just plus plus this is because of default values in Go. Everything starts off has a 0 value. Ints start off always at 0, so I can just plus plus it. Just gonna do this, see what I get. That seems reasonable. So what did I want? I want the biggest minus the smallest. So 2, 1, 1, 1, 1, 2, 1, 1, 1, 3. So the biggest is clearly 3818, and the smallest I have 1, 0, 1, 0, 1, 0, 1, 0. 1, 0 is the smallest, which is 1078. I'm just going to do that off screen. I'm getting this number, 2740. What do you get if you take the quantity of the most common element, subtract the quantity of the least common element? 2740. What do I get? Got it. Okay, next part. Part 2. The resulting polymer isn't nearly strong enough to reinforce the submarine. You need to run at least a total of 40 steps. This is a really big string. Okay, I don't think I can run this 40 times. Because this is what? Yeah, it's not even 2 billion. This is 2 trillion. 2 trillion. This is 2 trillion elements, which is not going to fit in memory. So, onto the real part of this question, which is how do we optimize this function? Let's take a look again at the rules. Oh, hey there. So I don't actually split. I'm not splitting Vim. This is tmux for splitting. So there's a question. Which plugin do I use for splitting Vim? Yeah, it's tmux to split the terminal. And Vim itself doesn't. I don't use splitting inside Vim. I very rarely do. Yeah, so this is a terminal, as you can see. And I'm just running a intra command. This is, you can install it on Homebrew to watch. So, let's see, no worries. Yeah, how do we do this? Okay, I wanna see the I want to see my rules again. Let's look at this mini example. In becomes nc. But nc and cn can do different things, right? And I'm sure they do. I guess n always expands to the exact same thing, right? No, wait, hang on. So n always expands to ncn, which always expands to nbccn, which always expands to this, which always expands to this, maybe? Or I don't even know how many n's I have to go up to. Huh. I wonder if you can do some kind of dynamic programming thing here. Because all we're interested in are the counts, right? We don't actually care what the final thing is. We just want to know what the counts are. Just gonna save this count somewhere so I can refer back to it later on if I need to. This is gonna take some thinking. Just to verify that I can't keep running this. Yeah, it dies pretty quickly after 12. It gets too long. Although actually this output is quite useful. Oops. This output is actually quite useful. Let's see. What we can say based on this input. I feel like we should be able to work backwards from this somehow. In N, you insert a C into it. So now I have NC and CN. But I know what NC and CN do, right? Because NC will insert a B, and CN will insert a C. What if my original input string was just NN? Like it doesn't help. I'm only going to be able to do like 5 steps more. I think I need a slightly simpler example. So I'm going to start with this. Oops. And I'm going to change this to just NN. And I want to see the first, let's say 10 steps of this. Oh, this is wrong. This needs to be a I+1, actually. Does it say? I have a question. Does it say ch will change to b? No. So it says if you read the instructions, it says it inserts it between the two, so it keeps growing. So like as you can see here, NN CB, NN becomes, it doesn't become the C. The rule is NN to C. It means you insert the C between the N's, and so it keeps growing. So the problem is to do this 40 times and then to count how many times each element exists in your final thing, except that that is going to overflow your memory, because even with the test input, it's going to have 2 trillion elements in there, and that's way too much to store in a string. I really feel like you can work backwards. So like, I really feel like you can work backwards. Like, NN will insert a C. I'm going to use this. NN will insert a C, which means if I started with NN, let me pull up a different document for this. If I start with NN, I end up with, after inserting, I will have in CN, which is 2N, 1C. Now, because I know I'm inserting a C, I know that NN becomes NC and CN. Right, so here's the first step. NN becomes NC and CN. And then because NC inserts a B, I know that, and okay, so I also know that NC becomes NB and BC, and I know CN becomes, I'm just reading off the bottom of my screen, CN becomes CC and CN. So we have these cycles, right? So after one loop, this is going to be 2n, 1c. This is going to be 1n, 1c, 1b. This is going to be 2c, 1n. So I know that NC, so if I want to work backwards, let's say I know I want to find out what happens at step 2. Can I just say, so after step 1, I have 1 in. After step, sorry, at step 0, I have 1 in. At step 1, I have 1 in C, 1 CN. Ah, maybe this is the way to do it. So at step 1, sorry, at step 0, I have 1 of that. At step 1, I have 1 of that and 1 of that. So at step 2, I'm going to have, okay, I think I'm kind of seeing this come together. At step 2, you should be able to consider each pair independently. I think that's the trick. I think that's the trick. Because NC becomes NB and BC. Now the only problem with this is that I'm going to be counting a whole bunch of elements twice. So I still got to figure out how to actually count this properly. But then after this step, I have 1 CC. So NC becomes NB and BC. And then CN becomes CC and 1 CN. So at step 3, oh, right, and the counts. Right, if we keep track of the counts, this is 2n. The count here is, right, plus C. Count here is plus B and plus C. So I'm going to write out the next step as well. NB becomes NB and BB plus B. BC becomes BB and BC, adds a B. CC becomes CN and NC plus N. Okay. So after the next step, I'm going to have I'm going to have an NB, a BB. BC becomes BB, BC. CC becomes CN, NC. I feel like I'm just reading off a whole bunch of letters. And CN, of course, becomes CC and CN again. Which means I now have 2 BBs and 2 CNs. And this is, of course, plus B plus N and plus C. Okay, so I'm just going to do one more cycle of this. BB becomes BN and then B, it's plus N. And do I have all the other ones? BC I have, CN I have, NC I have, CC I have. Cool. So now on the fourth step, I'm going to have NB, which becomes NB and BB. 2 BBs, so I have 2 BN and 2 NB. BC, so I have BC, so I have BB and BC. 2 CN, so I have 2 CC and 2 CN. NC, so I have NB and BC. And CC, I have CN and NC. And I forgot to do all the adds. So NB adds a B, 2BB adds 2N, BC adds a B, CN adds a C, 2CN adds 2C, NC adds a B, and CC adds an N. So we have 3N and 3B and 2C. And then if I collect this up, I have at least 2BB that I can see. I have 3CN now. I have 2NB. I have 4NB. Two BC. Okay, so something like that. So I have a track of all the elements that I have. Oh, it's some, wait, in the second step, there are 2 Bs added. In the second step, NC and CN. No, so there's actually only 1 B added. It looks like 2 Bs, but the chain itself, no, yeah, that's good to double check this stuff. But the chain starts off in N, and then it's in CN. And so then NC becomes NBC, and CN becomes CCN. So actually there's only 1 B added, but because you have to compare, so each element, except for the end elements, occurs in 2 pairs because you have to consider the first pair and the second pair. So it looks like there's 2 Bs, but actually it's just 1 B. If that makes sense? I hope that makes sense. They have a longer example here, and I've just shortened this example to only consider the double N. Yeah. So let me just count. I have my numbers on the bottom of my screen, so I'm just going to count. At step 0, I should have 2 Ns. At step 1, I should have 2 Ns and 1 C, which I have. At step 3, I should have 2 Ns. So you know what? Let's write this out. 2 Ns plus C. So it's 2N, 1C, plus B plus C. This is 2N, 1B, 2C, which is what I have. At the next step, I add 2 Bs, and an N and a C. So I should have 3 Ns, 3 Bs, and 3 Cs. Cool. Yeah, no, it's good to help. Thanks for reminding me to check though, because these are the things that are really going to get you, right? So 333, and I do have 333 here. So the next step is adding this. So this should be 6 Bs, 6 Ns, and 5 Cs. So it looks like this way of doing it works. So what we just need to do at each step is keep track of how many of each pairs we have. and also just keep track of the count, rolling count as we go. And that looks like it's going to work. So I'm just going to move that window to split that window off into a separate window. Okay, we worked out the rules. We worked out the rules. I'm gonna create a little struct, a type to hold this information because it's just a little bit more information. So I'm gonna call it step. It's a horrible name, but we're gonna say pairs is going to be a map of string to int, which is counting how many of each pair we have, and then this is the actual count of the elements is going to be count, like this. Okay. So I'm going to make a helper function called new step, which is going to give me a step, but it's going to just count it for me. So we can construct the pairs using one of the rules I had somewhere, something like this, to construct the pairs. S is going to be a step where pairs is initialized to be nothing, an empty map. Count is initialized to be an empty map. So for every pair, remember this -1 at the end because we're considering pairs. So we loop one less. The pair is going to be that, and then we're going to say s dot pairs pair plus plus. So so every time that pair comes up, it's going to increment the count of that pair. And then just to make sure we don't accidentally count things wrong, I'm going to loop it again. It's not efficient, but it's going to be a short string, so it's fine. I'm just going to say s dot count of each element as a string. Is going to increment as well. So if I come back up here and I, okay, at this point, I'm just going to say print new step, the string in. I should get, right, we have one pair of NNs and the count is 2. Oh, did I have my, I didn't save it. Okay, give me a sec. I'm just going to copy out that information. I'm going to copy out this map so we can compare our answer. Okay, so we just have something we can compare to. So we know that that's going to be there for us. Okay. So we need a new step function now. It's not going to look like this anymore. Step is going to be a bit of a misnomer, but it's okay. Which gives us a new step. I'm just going to initialize a new one. Call it out. Okay, so what do we do? What did we do in this algorithm? We need to know. Right, we need to do two things. First, we need to know what are the 2 new pairs that it produces and what is the count that it increases. So we'll just create those data structures to make it easier to use. Here, so it's not mapped to string anymore. It's a map of string to, so rules. I'm going to create some more helper types here. Output is going to be the pairs is going, well, should I call it pairs? I'll just call it pair 1 and pair 2. And then the count that it increases is going to be just gonna be a new element, really. Cool. So the way this works is I think this needs to be one of these things, maybe? I'm not sure. Just be safe. So rules K is going to be a new output of pair 1 is going to be the string K0 plus the value. Pair 2 is going to be the value plus K1. And the new element is going to be V. So those are my rules. I need to comment out all of my old code down here. Give me 1 sec. Okay, just got a couple more things. Chain declared but never used, and missing return. Right, I'm just going to return nothing for now. Out declared and not used. Fine, return out. Okay, this is a little bit annoying, so I'm going to try this and see if it likes it. Okay, it does like it, so that's okay. So that looks like what we want, right? So for example, in returns nc, cn, and c. In returns nc, cn, and c, which is what we want. So on one step, when we step, what we do is do we keep what we have? We don't keep what we have because n becomes the new pairs. So what we say is for each, we initialize the count. Okay, we initialize the count to be the same as the new count. The source, I can push, I'll put the source on in a jest later, if that's okay. Yeah, I'll put the source in a jest and link it in the description. I guess I'll have to tidy up first then. So first we want to copy the map. Maps, copying a map. So for kv in, I'm gonna call this in just to make it not mess myself up. Out.count k equals v. So just initialize it. If you really want, so I'm just looking at the chat. There's a Reddit subreddit for advent of code that gives hints and different interesting solutions as well. So that could be a really interesting that can be a really helpful way to like kind of slowly make your way towards a solution as well. Yeah, so it's just a bit of a comment there. I think for this specific one, it is a little algorithmic, and you do have to think about it. And for me personally, like trying to work out the algorithm is part of the fun. But I think everyone has different ideas, ways of doing these things. So I'm not going to judge. But the pairs okay, so we initialize the count. The output count is going to start this as the same as the input count, but the output pairs, because each input pair becomes the new pairs, we don't have to worry about copying the input pairs. So so for each pair in the input, right, we want to say out.pairs, well, no. So the outputs are going to be Output pairs are going to be my rules, which looks like this now. Whoops. Which is one of these things. I will say this specific one seems to be quite tricky. So yeah. So what is it? My rules, my input pair. Yeah. So those are the things. So out dot pairs t dot pair 1 plus plus, t dot pair 2 plus plus, and out dot count t dot new element plus plus. I think that will do it. That will be stepping through what the algorithm that we worked through earlier. Can't convert type int. Okay, my pairs. Oh, the other way around. Because the values are ints. Yes, it's the pairs are my keys, not my values. So we have a new step in, which gives us that. Now if I step that with my rules, do I get that second one that I was looking at? So we have Cn, Nc, and 1c and 2n. We have 1c and 2n. Oh, Cn, 1c. Yeah, okay, cool. I think this is pretty good. Okay, let me just do this so we can actually see it. This is actually slightly weird. S equals step S rules. Okay, let's compare it. We start off with NN and 2N. We then have CN and C and 2N and 1C. Then we have BC, CCC, and NB. BC, CCC, and NB. And we have 1B, 2Ns, 2Cs. We're going to go all the way down to step 4. We have 2 BBs, good. 2 BCs, good. 1 BN, maybe I just counted wrong. Maybe we do have 1 BN here, and I'm just counting it wrong. Yeah, I think let's just calm it down in the chat. It's okay. Everyone has slightly different ways of doing things, and that's okay. Nothing wrong with that. Either I made a mistake in my algorithm or I have made a mistake here. No, I made a mistake here because we should be having, I've missed something somewhere. How did I miss something? 333, we have 1 in C, 1 in B, 2 CN, 1 CC, 1 BC, and 2 BB. Ah, okay. I forgot to take the number of each element into account here because, yeah, I need to take the number of each element into account. So it's not plus plus, it's plus equals count, right? And this is also plus equals count. Because if I have 2 of something, I need to do it multiple times. I need to add it multiple times. Good, so I am up to 6, 5, 6. So I'm just gonna run this 10 times now, just to double check with that test input. And what do we have? 606, 89, 330. Okay, so it's looking good. It's looking good. Let me just put attach this back to my first window so I can see it. Okay. Oops. So we're going to do this, and this time we're going to change this not to be this, but we're going to use the actual input, which is going to be in CB. In 10 times, we should keep getting those numbers that they've written down on the screen. What was it? The most common element is B at 1749, 1749. The least is H at 161, H at 161. Great. In the above example, the most common element is B and H. So B and H still, but we have these numbers. So now this time we're going to run it 40 times. And I'm only going to print out the counts because otherwise it's too much. B should be 21920 whatever. Great. H should be that. Great. Okay. I think that is good. I'm gonna just chuck this in here now and use my actual data. My actual input. So that's my actual input with the result. Now I can't skim that with my eyes, so I will have to just write a quick loop here to find the smallest and the biggest. If v is less than min, min equals v. If v is greater than max, max equals v. Min max, min max minus min is this. So I actually want to run this on the test input once more, just to be double sure that I didn't write my min-max algorithm wrong. Min and max and min, which gives that. Good. That looks good. So here we go. This is my answer. Max minus min. Let's give it a go. We got it. Oh man. Oh, that was good. Okay, I took forever for that apparently. It was quite tricky. Yeah, I mean it's close to an hour. I'm gonna have to stop this real quick. It was quick. It was tricky. It was just coming up with how do you represent. This is like a representation problem, right? How do you represent all the information you need to know in a way that is efficient? So keeping it as a long string clearly wasn't efficient. How do you reduce that into something that tracks all the information you need in a way that is space efficient and time efficient? And this was one way to do it. So I will post up a cleaned up version of this in a gist a bit later. I might grab some dinner first. It is almost 7 o'clock in New Zealand. So, but yeah, afterwards, I'll chuck up a gist and link it in the description below. I've always wanted to say that, by the way. Just a cleaned up version. If you are interested in other ways to do this, there is a subreddit. I do believe it is just Advent of Code. And there people will be posting up solutions, hints, different languages, different ways to do it as well. And it's a really, really good resource if you are stuck. So that's another thing for you. And then just one final reminder that I will be traveling across the country tomorrow, so there is no stream on this channel tomorrow, unfortunately, but I will be back, or I'll try to be back the day after. So thanks so much for joining me. Yeah, this was a tough challenge, and I will see you again another time. Have a good morning, afternoon, evening, wherever you are.